Hello everyone and welcome to my CS663 Project 2 demonstration. In this video, I'll walk through my Android-based Sidewalk navigation assistant app. This project integrates on-device object detection using efficient det light 0 OCR using Google ML Kit and a narration system that summarizes scene information for accessibility. So I will also discuss how the code is structured and demonstrate light detection results, evaluate accuracy, and talk about what works well and what the limitations are. So let's get started. The goal of this project is to help visually impaired users navigate Sidewalk by identifying important objects such as stop signs, speed limit signs, benches, hydrants, and also reading text like street names or instructions. And uh, before demonstrating the app, here's a quick overview of the how the application works internally. And we have a couple of files that performs their own function. So that's the main activity files that uh, uh, which is handles the user interface, image capture and gallery selection. Then the object detector that loads the TensorFlow light efficient depth model and perform detections on bitmap. The OCR processor which uses Google ML Kit to extract text from images. The spatial analyzer uh, determines where objects are located relative to the camera frame. And here we have, the narration generator converts detection result and OCR text into short sentences. And the Gemini helper option, it integrates Google Gemini for contextual narration. And these all detections and narration results are passed into this result activity file, which displays bounding boxes over OCR overlays and the final narration message. Then the assets folder, this is the assets folder. This is where the model's t of light file is present. And there's also the labels.txt, which defines the label map which used during the detection. And now that the architecture is explained, let me jump to the running app in real time. So when I just run this, and it's going to be like this, appear screen like this, then yeah, and then it will give us display two options. This is the main vision assist interface. From here I can capture a photo using the camera or choose one from the gallery. For this demonstration, I'll just use the gallery images representing typical street and sidewalk conditions. And so let me just click on gallery. I'll just select this file. So I have several images to select from. For now, uh, I'll just select this one. Yeah, so the walk signal image, instruction sign. So the model, like as you can see, the model successfully identifies in this. And here if you see, the font might be hard to read, but you can see it says push button, wait for walk signal before crossing road. So you can see that the additional here is like before crossing road. That's an additional instruction from that is generated from the Gemini, as a part of fine-tuning Gemini. So these are the bounding boxes that that it shows that it has detected an object. Then the OCR that reads the textual information in it. So this demonstrates that the app can handle multi-line text and interpret in a safety oriented way. And then if you do it like play again,
push button, wait for walk signal
it's
before
gonna
crossing
give us
road.
the audio of that audio of this narration. And now uh, let's go to another image. Like let's choose as different image. So let's use the stop sign image. Let's see how it performs on that. And like as you can see, it just detects perfectly the OCR and the text, and everything is perfect. And what it says here is uh, see, so stop sign, stop, no parking within 30 feet. Yeah, so this case also contains a watermark text. So that's also probably why with the OCR sometimes capture an extra character. Despite this, the main street sign content is captured correctly. So if I play this
See
again,
stop sign, stop, no parking within 30 feet.
yeah, as you heard that this is, it plays an audio like just for the cost of the project, because we we were targeting the visually impaired users. So that's what that's all about. Now let me check with another photo. Right here I'm gonna choose this time, I'm gonna choose maybe, yeah, I'm gonna choose a speed limit sign. Let's see how it performs on that. And as you can see, uh, the object detector identifies the sign, and the OCR module extracts the number 35, and then it summarizes that like caution, like something. Yeah, it sometimes gives something. Yeah, 23rd and the street name, speed limit 35, 35. That's what it's in. If I play that, it's gonna,
Caution, 23rd and Schuyler Street. Speed limit, 35.
yeah, it just gave us like a caution and alert. So that's what it does. And this shows the ability to combine object labels, OCR, and street name recognition into a single message. Now if I just, now this time, let me see if there are any images other than that. Yeah, no, if I choose a blank image, so what it does, let's see. Yeah, if it's a blank image, uh yeah, what it says, like as you can see, uh, what happens here is there are blank white signs, and the OCR correctly detects that there is no text. And no, like it says, what is, does it say? It had blank street signs on the pole, buildings in the background. Yeah, that's what it said. There are no, it says that there are blank street signs. So uh, the OCR correctly detects that there is no text, and the app outputs that no objects or text detection in the scene. And this does demonstrate like proper handling of edge cases without producing false positives. And yeah, so across my test set of sidewalk and street images, the app like correctly recognized about 9 of the 10 scenarios, and the exceptions were that the other exceptions, sorry, I didn't mean to say exception, uh, that one image was like if there is low light, and the text is a bit blurry and depends on the camera of the uh, phone you're using. So that's where the that's where this app, it doesn't perform well in that kind of scenarios. So the object detection is strong for stop signs, benches, hydrants, and speed limit sign. OCR accuracy is highest for clean, high contrast text. So this model runs smoothly on Android emulator. So and is even faster on can be faster on real hardware. And uh, and what is some strengths of this system include that the object detection is reliable and accurate. The OCR is accurate for most street sign, and it gives a short and clear narration suitable for like assistive use, and it has a good spatial description of object location, and it has a stable runtime performance. There are a few limitations, like as I said, there are low light images reduce OCR confidence, and if there are watermarks in the image or style, text may be misread. So small distant objects can also sometimes go undetected, and blank signs return no relation as expected. And also the overall application performs very well and for real world sidewalk scenarios. and it can also like work with the camera, that's optional, but uh, I'm going to show it, probably show it how it works. So if I retake a photo and do a capture here, like if I'm using a real camera right here, if I do a capture here, and let's see what it does. Yeah, so as you can see, I know it's just flipped a bit, but it's going it's doing a wrong giving an accurate result. Like it says caution pedestrian crossing ahead, watch out for people walking. Yeah, uh, that's fine, right? Yeah, if I play
Caution.
it.
Pedestrian crossing ahead. Watch for people walking.
So that was a give. So overall the application performs very well for like real world sidewalk scenarios. So that's it for my project. This concludes my CS663 project 2 demonstration. So that's all. Thank you for watching and have a nice day.